Hello friends and my dear students, I welcome you all to my channel. I hope your studies are going well and you're all well. And I hope that you are doing a proper revision of all your subjects, including mathematics, every other alternate day, because as I always say, that gives a good revision of all the subjects. So this is part 4 video on the chapter of time and work, where I will discuss about how pipes and cistern works. That is the working principle of pipes and cistern. A cistern is also known as a tank. So pipes, there are pipes that will fill a cistern and there will be pipes that will empty a cistern. So when they work individually, what is the work done by them and how much time it takes for the pipes to empty the tank or fill the tank. All these functionality and the formulas we will discuss. If you have not watched the previous 3 videos, part 1, part 2, part 3, where I have discussed about the general rules of work and time, and I have solved some selected problems of exercise 13A, then I strongly suggest that you watch those videos also to maintain the continuity of your study on this chapter of time and work. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with the part 4 video on pipes and cistern from the chapter of time and work. Okay, so I have prepared some rough notes that I will discuss about the pipes and cistern, and at the end of the discussion of the concepts, I will solve 4 problems as example problems to describe or to understand how we will apply the concepts learned in this video to solve some problems. Okay, so this is about pipes and cistern. Cistern is also known as tank. A tank and cistern is the same thing. So this is all about filling a tank with some water or empty a tank by some pipes. Now the pipes or tap. So the tap that fills a tank with water is known as inlet, and the tap that empties water from a tank is outlet. That is, if a tap is an inlet, then water is being filled from by that tap in the tank, and if a tap is an outlet, that means water is coming out, or water is being emptied from the tank. So these are the 2 types of taps that we will work with. So it is all about a tank being filled with water or being emptied with water by some inlet or outlet taps. Now there are fundamentally 2 rules that we need to understand about inlet and outlet taps and a tank being filled and emptied by water. And there are some other results that we should also know and understand based on these 2 rules. So the first rule is that if an inlet means a tap that is that fills a tank. So if an inlet can completely fill an empty tank in X hours, then what does it mean? What information do we get from the fact that an inlet? So as you can see the arrow marks, there are 4 information we need to understand and know when it is known to us that an inlet can completely fill an empty tank in X hours. That is, if there is an inlet tap connected to a tank and the tank is initially empty, and you open the inlet tap, then in X hours the tank will be completely filled with water. From this fact, what we can say? The first thing we can say is that part of the tank filled by the inlet in 1 hour is will be equal to 1 by x, will be equal to 1 by x. So this is the first part we know, that is in 1 hour this 1 by x will be the part, 1 by x will be a fraction, since x hours will usually be some integers, will usually be some positive integers. It could also be a fraction like 3.5 hours or 4.5 hours, but usually mostly I think you will deal with problems where the x hours will be given, x will be given as natural numbers like 6 hours, 8 hours or 10 hours. So definitely 1 by x will be a fraction. So the 1 by x is the fraction of the tank that will be filled by the inlet in 1 hour, when it is known that the tank is being, an empty tank is completely filled by the inlet in x hours. So this is the first information we know. The second information we know is that the work done by the inlet in 1 hour is 1 by x. Now, the work done uh, regarding a tank being filled or emptied by water, the work done will be positive. Sometimes it will be is positive. The work done will be positive when a tank is being filled by water. So since an inlet tap fills the tank with water, it is doing positive work. So an inlet tap always does positive work, and the work done by an inlet tap in 1 hour will be 1 by x, and this is positive work. Okay. Now, so the first two are quite related to each other. That is, as you can see, the value of the first two are both 1 by x. So you can consider the 1 by x as the fraction of the tank being filled in 1 hour, and also it is the work done by the inlet tap in 1 hour. Okay. The third one is that time taken to fill P by Qth part of the tank by the inlet will be equal to P by Q multiplied by X hours. Now this P by Q will be a proper fraction, that is P is less than Q. So this is a proper fraction. So if we know that an inlet tap can fill an empty tank, completely fill an empty tank in X hours, then we can say that P by Qth part of the tank will be filled by the tap in P by Q multiplied by X hours, and this formula is no rocket science. It is just we just apply a unitary method. So how? We know the fact that the inlet tap in X hours is completely filling the tank Now the complete tank, that is the full tank, is considered to be 1. So 1 is a positive work done of 1 means that a whole tank is being filled. Okay, so we know that we know that one part of the tank, since a full tank means one part, one means a whole part. So we know that the one part of the tank is being filled in X hours. So definitely P by Qth part of the tank will be filled in P by Q multiplied by X hours. This is just applying a basic unitary method. So this was the third result. The fourth result is that what part of the tank will be filled by the inlet in Y hours. So that will be 1 by x multiplied by y. This is also based on unitary method, because we know that in 1 hour the first result says that in 1 hour 1 by x part of the tank is being filled. So definitely in y hours 1 by x multiplied by y, that is y by x part of the tank will be filled. Now it is absolutely not necessary to remember all these formulas. These should come by common sense. I have mentioned these as results just to know, just to make you understand that these are the fundamental results or concepts that we should keep in mind. Okay, now let's see. Let's try to understand this with an example. So let's say an example. Let's say an inlet fills a tank. Now, by fills a tank, I mean it is filling completely an empty tank. Let's say an inlet fills a tank in 4 hours. 4 hours. So this will imply that so the first result, we know that so in 1 hour, so we can say that in 1 hour, 1 by 4th part, that is 1 by 4th part of the tank will be filled. Now, I am not writing filled by water. It is assumed that it is understood that it is being filled by water. So, we can say that in 1 hour, 1/4 part of the tank will be filled. Okay. The second result is that work done in 1 hour, is equal to 1 by 4. So the work done is basically for an inlet tap, the work done is equal to the part of the tank filled in 1 hour. So in 1 hour, the part of the tank being filled by water is equal to the work done in 1 hour by an inlet tap. Okay. Now let's say so this is the work done in 1 hour. So whenever you see, so if it is known that the work done in 1 hour is equal to 1 by 4, it means that 1/4 part of a tank is being filled in 1 hour. Okay. Now let's say time taken. So what will be time taken to fill, let's say to fill three, not three, let's say time taken to fill 3 by 4th part, 3 by 4th part of tank will be equal to 3 by 4 multiplied by 4 hours, which is equal to 3 hours. So if the inlet is filling a tank, is completely filling an empty tank in 4 hours, then we can see that 3 by 4th part of the tank will be filled in 3 hours. Okay. Now let's see how much part, or what fraction of the tank will be filled by this inlet in let's say in 2 hours. So fraction or part, it is same thing. Fraction or part of tank filled in 2 hours will be 1 by 4. 1 by 4. So you see the formula is 1 by x multiplied by y. So 1 by 4 multiplied by 2, which is equal to half. So it is quite obvious that if in 4 hours the inlet can completely fill an empty tank in 4 hours, then obviously in 2 hours it will only fill half of the tank. So I hope this example will give a little more clarification of the results that we discussed in as rule number one. So rule number one is talking about inlet tap. Okay. Now the rule number two is about outlet tap. So the rule number two says that if an outlet, that is an outlet means a tap uh, which is which is emptying a tank. So if an outlet can empty a completely filled tank in y hours. So if a tank is completely filled and the outlet is taking y hours to empty the tank, that is bring out to empty the entire water in the tank in y hours, then what results we can have from this fact? It is quite similar. It is quite similar to the rule number one. Let's see. So the result one is that the part of the tank emptied in 1 hour is 1 by 5. So this time, since an outlet empties a tank, the part of the tank emptied in 1 hour is 1 by 5. So this is the first result. The second result is that now for an outlet, since an outlet empties a tank, the work done which is negative. So this is very important to understand that an inlet tap, the work done by an inlet tap is positive, and the work done by an outlet tap is negative. So for an outlet tap, the work done in 1 hour will be minus 1 by y. Remember that y is not negative, y is positive, because it will be given that an outlet tap can completely can empty a completely filled tank, let's say in 4 hours or 6 hours. Then if it is 4 hours, then the work done in 1 hour by the outlet tap will be minus 1 by 4. So whenever you see a work done, whenever we have a work done in 1 hour by some taps is negative, this means that water is being emptied. Water is being emptied. Okay. So we have work done by the outlet in 1 hour is minus 1 by 5. The third result is that time taken to empty P by Qth part of tank by outlet will be P by Q multiplied by Y hours. This is very similar to the rule 1 results, but this time the time taken to empty, not fill, but time taken to empty P by Qth part of the tank by the outlet is P by Q multiplied by Y hours. And the last result is part of the tank emptied by outlet in X hours is 1 by Y multiplied by X, that is X by Y. Now let's try to understand these results with an example. So let's say an outlet, it is given that an outlet empties a completely filled tank in, let's say, 6 hours. So when an outlet that is an outlet a tap is connected to a cistern or tank and the tap is open, when the tap is open, then water is definitely coming out from the outlet, and so the tank is being emptied, and so the outlet will take 6 hours to completely empty the tank. The tank is completely filled with water, and then when you open the outlet tap, then it is taking 6 hours to completely empty the tank. So this is what it means that an outlet empties a completely filled tank in 6 hours. So what results do we get from this fact? So what is the, so we can say that part, so we can say that 1 by 6th part of the tank is emptied in 1 hour by the outlet in 1 hour. So 1/6 part of the tank will be emptied in 1 hour. The work done in 1 hour will be equal to minus 1 by 6. Why negative? Because it is a convention that the work done by an outlet is negative and the work done by an inlet is positive. That is, when a tank is being filled with water, the work done is positive, and when the tank is emptied, then the work done is negative. Okay. What the third result we can say? Let's say, so we can time. Let's see, time taken to empty. Time taken to empty. Let's say uh, two-third two-third of tank. Time taken to empty two-third of tank by this outlet, by the outlet, will be equal to two-third, that is the fraction 2 by 3 multiplied by 6 hours. This is equal to 4 hours. So in 4 hours, this outlet can empty two-third part, two-third, 2 by 3 part, two-third of the tank. Okay. Now let's see. Let's see. Time take. Okay. So let's see. How much time? Yeah, so let's see what part of the tank will be emptied by this outlet in, let's say, so part of the tank being emptied by the outlet in, let's say, 4 hours will be equal to 1 by 6 multiplied by 4, which is equal to 2 by 3. So part of the tank being emptied by the outlet in 4 hours will be equal to 1 by 6 multiplied by 4. So what is why 1 by 6 multiplied by 4? Because 6 is the hours it takes the outlet takes to completely empty a filled tank. So 1 by 6 multiplied by 4, which is 2 by 3. So 2 by third, the fraction 2 by third part of the tank will be emptied in 4 hours by the outlet, based on the fact that an outlet empties a completely filled tank in 6 hours. I hope this example will give a better clarification of how of the results regarding an outlet tap. So these two rules, rule 1 and rule 2, are the fundamental two rules based on which we can we should know and understand some derived results. So there are there are 3, 4. Okay. So based on the rule 1 and rule 2, based on rule 1 and 2, I have listed down, or I have written down some further results that you must understand while to solve problems. So the next one is that if work done in 1 hour by the inlet or outlet taps A, B, and C are 1 by x, 1 by y, and 1 by z respectively, then what we can say when all the taps are working together. Now, it is not mentioned whether the tap A is an inlet tap or outlet tap, or tap B is an inlet tap or outlet tap. The nature of the taps A, B, and C are not known. It is just known that in 1 hour the work done by tap A is 1 by x, in 1 hour the work done by tap B is 1 by y, and in 1 hour the work done by C is 1 by z. Now it is possible that x, y, z could be positive. The values of x by z can be positive or negative depending on whether the tap is an inlet tap or an outlet tap. So if we know the work done by these three taps A, B, and C in 1 hour, then when all the taps are working together, all the taps are working together means all the taps are open. Then we can say that work done by A plus B plus C means that all the taps are open or all the taps are working together. So work done by A plus B plus C in 1 hour will be equal to 1 by x plus 1 by y plus 1 by z. Now, if this net result is coming out to be positive, then we should understand that water is being filled in 1 hour to the tank. And if this net result is negative, then it means that in 1 hour water is being emptied from the tank. Okay. Now I have left some space. I was thinking to explain this result with some example, but I think it will unnecessarily make the video long. I think when I will solve some examples, it will be clear. So I will skip explaining these results with an example because it will take a lot of time, and I think it will be redundant. So just know that if we know that in 1 hour work done by a tap is 1 by x, irrespective of the fact that whether the tap is inlet or outlet. If the tap A is an inlet, then definitely x will be positive, and if the tap A is an outlet, x will be negative. Similarly for the taps B and C. So if you know that in 1 hour work done by the tap A is 1 by x, and the work done by the tap B is 1 by y, and the work done by the tap C is 1 by z, then when all the taps are working together, that is when all the taps are open, then the net work done in 1 hour by the three taps will be 1 by x plus 1 by y plus 1 by z. Okay. Let's see the next result. Okay. Now this is a good important result, not result actually, concept. So if net work done in 1 hour by some working pipes is 1 by n, what does it mean? So let's say some pipes are working, it could be one pipe, let's say some taps are working, it could be 1 tap, it could be 2 tap, or it could be 3 taps, or any number of taps. Some taps are working, that is they are open. Working means they are connected to a tank, so they are either filling the tank with water or they are emptying water from the tank, depending on whether the tap is a inlet or an outlet. So some taps are working, and the work done by all these taps in 1 hour is 1 by n. So that is what I mean by saying net work done in 1 hour by some working taps is 1 by n. Then what we can say. So it will depend whether n is positive or negative. Now if n is greater than 0, that is if n is positive, this will mean that the tank is being filled per hour, that is the tank is being filled with water per hour. So in that case we can say that the time taken to completely fill the tank by the taps will be n hours. So if n is positive, then we can say that the whole tank will be filled up by water in n hours, where we know that the work done in 1 hour by the taps is 1 by n. And if n is less than 0, that is if n is negative, then it means that per hour water is being emptied from the tank. So in that case, we can say that time taken to completely empty the tank by the taps will be n hours. I hope you have understood this concept. Mm, uh, Now, if I try to explain this with an example, it will make the video long, so I'm not really going to do it. But do not worry, when I will solve some problems, these concepts I will apply and it will be clear to you. But please remember that you have to solve a lot of problems. Definitely, you have to solve all the problems from your textbook, whatever textbook you are following, and also any other reference books. And if you are following my videos, and if you and so all the problems that I will solve from the textbook of author RS Aggarwal and the problems that I will give as part of homework assignment, these all these problems will be sufficient to have a good understanding of the basics, fundamental concepts of this chapter. Now for harder problems, you have to see my other playlist, that is Maths 8 Hot, where I solve 10 harder problems, relatively harder problems from each chapter. Okay, now I think these are all the concepts that I think are important to keep in mind and understand to solve problems on pipes and cisterns. Now let's solve few example problems to or see how we are applying these concepts to solve the problems. I will not solve any. So these example problems are mostly I think that they are taken from the example problems from the textbook of author RS Aggarwal. Uh, so I'm not going to solve any exercise problems in this video. In the next video, I will solve the remaining problems of exercise 13A from the textbook of author RS Aggarwal, which are based on pipes and cisterns. That will be the next video. Okay, now let's solve these problems. The first, not example problems. The first one says that a tap A can fill a tank in 4 hours while tap B can fill it in 2 hours. This means that tap A can completely fill an empty tank in 4 hours. Similarly, tap B can completely fill a tank which is completely empty initially in 2 hours. In how much time will the tank be filled if both A and B are open? That is, open means it is working. Now, so both tap A and B are working together is the same as saying that both tap A and B are open. Okay. So, how do we proceed? Now, the question is, in how much time will the tank be filled if both A and B are open? To answer this, we must know in 1 hour how much, what part of the tank is being filled when both A and B are working together. Or it also means that what is the work done in 1 hour when both tap A and B are open. It means the same thing. So let's say, so we know that. But before that, we must know or find what is the work done in 1 hour by the taps individually. Now, since both the taps A and B are filling the tank, they are inlets. So, work done by tap A in 1 hour will be equal to 1 by 4. Since it is given that in 4 hours the tap A completely fills an empty tank. So, the work done by the tap A in 1 hour is 1 by 4. Since it is 1 by 4 positive, since it is filling the tank. Similarly, we can say work done by tap B in 1 hour is equal to 1 by 2. Since it is given that B completely fills an empty tank in 2 hours. So this implies that work done by tap A plus B means that both the tap A and B are working together, or both the taps A and B are open. So work done by taps A and B in 1 hour will be equal to 1 by 4 plus 1 by 2, which is equal to 3 by 4. 3 by 4. Now, okay. Now, so if you know that in 1 hour how much work is done, then we can say and if the work done is positive, then we can say that water is being filled. Then we can say how much time it will take to completely fill the tank. So 3 by 4 can be written as 1 by 4 by 3. 1 by 4 by 3. So if you know that work done in 1 hour is 1 by 4 by 3, and since it is a positive, we can say that time taken by A plus B to completely fill the tank will be equal to 4 by 3 hours, which is equal to 1 and 1 by 3 hours, which is equal to 1 plus 1 by 3 hours. So whenever you have any hours, yeah, as a mixed fraction, 4 by 3 is a mixed is an improper fraction. So in mixed fraction it is 1 and 1 by third. Then you should always convert the hours into hours and minutes. So this is equal to 1 hour plus 60 by 3 minutes. This is equal to 1 hour and 20 minutes. So when both the taps A and B are working together, or they are both open, then it takes 1 hour and 20 minutes to completely fill an empty tank. Okay. So the idea was to find initially to first we find the work done by the tap A in 1 hour and the work done by the tap B in 1 hour. Since both the taps are filling the tank, the work done will be positive. Now we need to find what is the total work done by the tap A and B in 1 hour, which is 1 by 4 plus 1 by 2, which is equal to 3 by 4. Now 3 by 4 we have written in the form of 1 by n, where n is 4 by 3. So if you know that the work done in 1 hour is 1 by n, now remember that the work done means it is either filling the tank or emptying the tank. Now since the work done is positive, then it is filling the tank. So if you know that the work done in 1 hour is 1 by 4 by 3, we can say that the whole tank, the complete tank, will be filled in 4 by 3 hours. Now I could be I'm prone to make calculation mistakes, so let me quickly check if the answer is correct or not. I think this example is taken from the book itself. Let me check. A type 4 hours, 4 hours. Oh no, that is an example from the book itself, but I have changed the figures. In the book, it is given tap A fills the cistern in 8 hours and tap B fills in 4 hours. Anyway, okay. So the answer is 1 hour and 20 minutes. Now, if you see any kind of calculation mistakes in solving any problems, then please do let me know in the comment section. I will highly appreciate that. Okay. Next problem is tap A can fill a cistern in 4 hours and tap B can empty the tank in 6 hours. If both the taps are opened together in the empty tank, in how much time will the tank get filled up? So we are given two taps. Tap A is an inlet because it fills a cistern, Cistern means a tank, and tap B is an outlet because tap B empties a tank. So tap B can empty a tank in 6 hours, means that if a tank is completely filled, then it can completely empty the tank in 6 hours, and the tap A can completely fill an empty tank in 4 hours. Okay, so first we need to find the work done by the individual taps in 1 hour. So work done by tap A in 1 hour will be equal to 1 by 4. Since it is given in 4 hours, the tap A can completely fill a cistern. Similarly, work done by tap B in 1 hour will be negative minus 1 by 6, because the tap B is an outlet. It is emptying a tank, and it empties a completely filled tank in 6 hours. So the work done by tap B in 1 hour will be negative of 1 by 6. So now we need to find what is the net work done by the tap A and B in 1 hour. So work done by A plus B in 1 hour will be equal to 1 by 4 minus 1 by 6. This is equal to 3 minus 2 by 12, which is equal to 1 by 12. So when both the taps are working together, that is, they are open in 1 hour, the work done by them is 1 by 12. So clearly from here we can say that now since the work done is positive, 1 by 12 is positive, it means that in 1 hour per hour the tank is being filled, and that means in 1 per hour 1 by 12 part of the tank is being filled with water. So we can say that time taken by A plus B to completely fill the tank will be equal to 12 hours. Because if we know, so the concept is that if work done in 1 hour is 1 by n, where n is positive, then we can say that the whole tank will be filled in n hours. And if if n is negative, if we know that the work done in 1 hour is minus 1 by n, then we say that the whole tank can be emptied in n hours. So the answer is 12 hours. Okay. I'll quickly check whether this problem is taken from the book or not, and if my answer is correct or not. 12 hours is correct answer. So this problem is exactly taken from the example problem from the textbook of author RS Aggarwal. Okay. I think the next problem is also no. The third problem is, I think I made this problem myself. Anyway. Oh, okay. So third problem says tap A and B fills an empty tank in 2 hours and 3 hours respectively. So that is, both tap A and B are inlet taps. That is, they fills a tank. The tap A completely fills an empty tank in 2 hours, and tap B completely fills an empty tank in 3 hours. Okay. Tap C empties a filled tank in 2 hours. So tap C is an outlet, and it takes 2 hours for tap C to completely empty a filled tank. Now all the taps are opened in an empty tank for 1 hour. So for 1 hour the taps A, B and C are working together, that is they are all open for 1 hour, and it is asking what will be the status of the tank after 1 hour, that is after 1 hour what will be the state, by status it means that how much what part of the tank will be filled with water, or whether or what part what part will be filled or empty. So it is this by status it is asking that whether the tank will be completely filled, or if it is not completely filled, then what part of the tank will be filled, if at all it is filling, if at all water is being filled, because if the net work done the tap A, B and C is, if the net work done by the tap A, B and C in 1 hour is positive, only then we can say that some part of the tank will be filled in 1 hour, and if the net work done by the tap A, B and C is negative, then we can say that the tank will never get filled by any water, because the tank is the tank is initially empty. The tank is initially empty. Okay. So now, so we see work done by tap A in 1 hour. Since tap A fills the tank, so work done by tap A in 1 hour will be 1 by positive 1 by 2. Similarly, work done by tap B in 1 hour will be equal to 1 by 3 positive, since tap B is also an inlet, that is it is filling the tank. For tap C, the work done will be negative, because the tap C is empty, it empties a tank. So the work done by tap C in 1 hour will be equal to minus half, is equal to minus half. So this implies a work done by taps A plus B plus C means all the taps are open or working together in 1 hour will be equal to half plus 1 by 3 minus half. So minus half gets cancels out, and we are left with 1 by 3. Now 1 by 3 is a positive work done, which means that per hour water is, so as a net result per hour water is being filled in the tank. So definitely in 1 hour some part of the, if not fully, some part of the tank should be filled by water. Okay, so we are having a work done by all the 3 taps in 1 hour is 1 by 3. So, and it asked, so they are working for all the taps are opened in an empty tank for 1 hour. So after 1 hour, so this implies, so definitely we can say that 1/3 of the tank is filled by A plus B plus C in 1 hour. Now work done in 1 hour is equal to 1 by 3 means that since it is 1 by 3 is positive, it means that 1/3 part of the tank is being filled in 1 hour by the taps. So the status is that after 1 hour 1/3 of the tank is filled. 1/3 of the tank is filled with water. So this is the status of the tank after 1 hour. Okay, let's do the next problem. It says that taps A and B can fill an empty tank in 4 hours and 6 hours respectively. Taps C and D can empty a tank in 8 hours and 2 hours respectively. So taps A and B are inlet taps, and tap C and D are outlet taps. Okay, they are all opened in an empty tank for 3 hours. So the tank is initially empty, and obviously all the 4 taps, that is tap A, B, C and D, are connected to the tank, and the tank is empty and all the taps are opened, that is they start working together. what fraction of the tank is still empty? Oh, so all the taps are working for 3 hours. So it is asking after 3 hours what fraction of the tank is still empty. Okay, now first we have to check what is the work done by all these 4 taps in 1 hour. It should be positive. Only then per hour the tank will get filled up. And if the net work done by all these 4 taps in 1 hour is negative, then never then the tank will never get filled up by water. Okay, so let's see. Uh, work done work done by tap A in 1 hour is equal to, since A is filling the tank, it is an inlet, so the work done will be positive. So work done by A in 1 hour is 1 by 4, since it is given that it takes 4 hours for tap A to fill completely an empty tank. Similarly, work done by tap B in 1 hour will be equal to 1 by 6. Since tap B is also an inlet, it takes 6 hours to completely fill an empty tank. So the work done by tap B in 1 hour is 1 by 6. Similarly, we will have work done by tap C in 1 hour will be negative. Since the tap C and D are outlet, they are emptying a tank. So work done in 1 hour by tap C will be minus 1 by 8, and work done by tap D in 1 hour will be equal to minus 1 by 2. So work done, now we need to find what is the work done by all these 4 taps in 1 hour. So work done by A plus B plus C plus D in 1 hour is equal to 1 by 4 plus 1 by 6 minus 1 by 8 minus 1 by 12. So the LCM will be 24. LCM will be 24. So 6 plus 4 minus 3 minus 12. So we can see that it is coming out to be negative. So work done by A plus B plus C plus D in 1 hour is, let me quickly check if I am doing correctly or not. Work done by A in 1 hour is 1 by 4. Work done by B in 1 hour is 1 by 6. Work done by C in 1 hour is minus 1 by 8. And work done by D is minus 1 by 2. So work done by all the taps when they are open or they are working together, work done by all these 4 taps in 1 hour should be 1 by 4 plus 1 by 6 minus 1 by 8 minus half. This is equal to LCM will be 24. So 6 plus 4 minus 3 minus 12. So this is coming out to be 10 minus 15 by 24, which is minus 5 by 24. It is coming out to be negative, which means that per hour water is being emptied. Water is being emptied. Now the tank was initially empty. Now per hour the work done is empty. This means that no water is being filled up. No water is being filled up per hour. This means that the tank will never get filled up by any water. Now it is asking that what fraction all these 4 taps are working for is working for 3 hours. So also in 3 hours no water will get filled up in the tank because the work done per hour is negative. If the work done per hour is negative, this means that water is being emptied and no water is being filled up. So definitely, so what will be the answer? What fraction of the tank is still empty? The whole tank will be empty. After 3 hours, the whole tank will be empty, which means that the answer is 1. So this implies that no water. I gave the wrong data. My intention was not to end up with this kind of solution that the tank will not be filled. uh, I was so the data that I gave, that is the hours 4, 6, 8 and 2, these are improperly given by me. So that is why we are having the answer that no water is being filled per hour. This was not my intention. So I could not frame this question properly. I'm sorry for this. But anyway, I hope we are learning anyway something from this problem. So we can say that if the work done in 1 hour is negative, then we can clearly say that no water is being filled up. No water is being filled up per hour in the tank. No water is being filled up per hour. This implies that the tank the tank will never be filled up by any water. The tank will never be filled up by any water. Uh, the tank will never be filled up by any water, irrespective of for how many hours the 4 taps are working. So this implies the tank will always be empty. This implies that after 3 hours, fraction of tank still empty is obviously 1, even though this solution was not intended, but since I could not give the proper data, the solution we got is that the tank is never being filled up. But this was not my original intention, so I'm really sorry for this. But anyway, I hope you understood one thing, that if the work done per hour by some taps is negative, then it means that per hour no water is being no water is being filled in the tank, which also means that the tank will never be filled by any amount of water, no matter for how many hours the taps work. And conversely, if the work done in 1 hour by some taps is positive, it means that eventually it means that some per hour some water is being filled in the tank, which means that eventually in some hours the tank will be completely filled with water. Or we can say that if the work done in 1 hour is positive, then the tank, if it is completely filled, it will never be emptied. It will never be emptied. So this was all about. So this is the 4 examples that I wanted to solve to clarify how we are applying the concepts that we studied about pipes and cisterns to solve the problems. Even though these 4 problems definitely do not cover all the variations of problems that are possible regarding pipes and cistern, I will definitely cover all the problems when I will provide assignment problems. The next video after this will be solving the remaining problems of exercise 13A, which are based on pipes and cisterns. And once that is complete, I will provide 2 homework assignments I will provide another 2 homework assignments based on pipes and cistern, or maybe one. I think one will be enough. That will that should cover the most range of questions that can come from cistern and pipes. But these problems in the problems in assignment problems and the problems that we do from the RS Aggarwal textbook, they are not really hard problems. The hard problems I will cover in the other playlist, that is maths, in the playlist maths 8 hot. So please keep an eye in that playlist when I will solve 10 good problems from this chapter of time and work. So I will end this video here. I hope this video was beneficial for you to understand the concept of pipes and cistern tank related to time and work. And if this video was beneficial, please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So thanks for watching, and until the next video, take care and bye.